All right, let's talk about something almost every developer gets wrong at some point: authentication. We're going to see that the most bulletproof systems aren't built on super complex code, but on answering one single, really powerful question first.
So let's just dive right in, because this is the whole point. Why is it that the most senior, most experienced engineer on your team will grab a whiteboard instead of their keyboard when you ask them to build security? The answer, I promise, is going to completely change how you approach this stuff from now on.
And this slide just nails the difference. On the left, you've got the typical reactive approach, right? You think, okay, auth, so you npm install some library and start messing with tokens. It's all about the how. But look over on the right. The staff engineer isn't thinking about libraries yet. They're designing an identity model. They're focused on the who and the what. And here's why. They know that most security breaches don't come from bad crypto. They come from a bad model of who's even allowed to be in the system in the first place.
So, here it is. This is it. The one question that really separates a system that's going to break from one that's going to last. Before you even think about passwords or JWTs, you have to ask yourself, is the thing performing an action in my system a human, a machine, or, as you'll find is often the case, both? The answer to this question shapes your entire architecture.
To solve this, we need a really powerful, simple idea. It's called the principle. You can just think of a principle as the unified concept for any actor. It just doesn't matter if it's a person clicking a button on your website or a cron job running on a server at 2 a.m. To your system, they are both simply principles trying to get something done. This idea, this is the bedrock of a modern security model. Let's make this a little more real. Your human principles are, well, they're exactly who you think they are. Your customers logging in, your own employees, system admins, you get it. But look at the machine principles. These are the ones that everybody forgets about in the first design pass. That nightly billing job, that's a principle. A microservice that needs to talk to another microservice, that's a principle. Even your build pipeline that needs to deploy new code, yep, that's a principle too. All of them need to be authenticated. And this quote, honestly, you should print this out and tape it to your monitor. This is the mantra. Your API shouldn't care if the caller is a human or a robot. It future-proofs everything. Instead of asking, is this a user, your code should only ever have to ask one thing. Does this principle have permission to do what it's asking to do? That's it. Okay, so we've got our actors identified as principles. But now for the next piece of the puzzle, once they're logged in, how does our system remember who they are on every single request that follows? Well, this is where a fantastic analogy comes into play. Passports versus guest lists.
So on the left, you've got the old way of doing things, the guest list. This is stateful. When someone logs in, the server writes their name down on a list, usually in a database. Then for every single action they take, the server has to go look them up on the list again. It's slow. And in a world with tons of microservices, it becomes a gigantic bottleneck. Now, look to the right. This is the passport model using JWTs. It's stateless. The user is given a cryptographically signed passport, their token, and they just carry it with them. No database lookup, it's wicked fast, and it scales like a dream.
You know, the best part is how simple and elegant this flow is. Step 1, the principal, human or machine, logs in and gets their passport, which is assigned to JWT. Step 2, they carry that passport with them, usually in the header of every API call they make. And step 3, they just show their passport to whatever service they need to access. The service just checks the signature, makes sure it's not fake, and that's it. No phone calls back to headquarters. Okay, so we've covered the high-level model. We've got our stateless token. Now let's bring it all the way down to the code that actually checks the permissions. And this right here is where you can tell an amateur from a pro in about 5 seconds. Here is the brittle, fragile way to do it, and I'm willing to bet you've seen code exactly like this. It's checking if the user is a manager. Seems simple enough, but it's a trap. Why? Well, what happens when that nightly billing service, our machine principal, needs to run a report? Is that machine a manager? No. So now you have to start hacking this code, adding special cases, and it just becomes a giant security mess. Now, contrast that with the flexible way. Look at this C# code. We are not checking who the caller is anymore. We are checking what they can do. We've defined a policy, a capability, called can-read reports. And now any principal, whether it's a human manager or that automated building service that has the reports.read claim, think of it like a stamp in their passport, is allowed in. It's clean, it's decoupled, and it works for every actor now and in the future. But listen, Even if you do all of this perfectly, there is still a very subtle and incredibly dangerous architectural trap waiting for you. It's called the confused deputy problem, and it's how a perfectly trusted service in your system can be tricked into doing a bad guy's dirty work. So let's just walk through the attack. Step 1. You've got Alice. She's a low-privileged user, but she sends a tricky request to your front-end API. Step 2. The front-end API needs to get some data to fulfill that request, so it calls the database API. But here is the critical mistake. It uses its own powerful high-privileged service credentials to make that call. So in step 3, the database API sees a request from its trusted buddy, the front-end API, and just sends back the sensitive data. It has no idea that this data is actually for Alice, who should never, ever be allowed to see it. The front end has become a confused deputy. So how in the world do we fix this? We use a pattern called identity propagation. Look at how the flow changes. Step 1 is the same. Alice makes a request. But step 2 is totally different. This time, instead of using its own credentials, the front-end API takes Alice's original token and passes it along to the database API. This is sometimes called an on-behalf-of flow. And now, in step 3, everything is different. The database API isn't checking the front-end's permissions, it's checking Alice's permissions. It sees she isn't allowed to see that data, and boom, it correctly blocks the request. Trap avoided. So let's just quickly recap the 3 core architectural rules we've talked about. Number 1, unified identity. Treat every actor, human or machine, as an abstract principle. Number 2, check claims, not roles. Secure your system based on what the principal can do, not who they are. And finally, number 3, propagate identity. Always pass the original caller's identity all the way downstream so your services don't get confused. You know, getting this model right from day one is what saves you from having to rewrite your entire security system 2 years down the road. So, I guess the final question I want to leave you with is this. Go take a hard look at your own systems. Is your security built on a deliberate, flexible model, or is it built on a mistake that's just waiting to happen?